In this example, we have a plane that has a northwest heading at a rate of 450 miles per hour. There's also an easterly wind blowing at 60 miles per hour. So this question here, and we're going to write all this stuff out, but the first part of the question wants us to express each velocity as a vector. So I'm going to be kind of, simple here, and let's say that vector P is going to be for the plane, and vector W is for the wind, right? That way we don't have to really think about what they are. P is plane, W is wind, all right? So for the vector for the plane, we want to have its magnitude, which is 450 times that angle measure. Now, it might be good to draw a picture to make sure that we were going in the right direction, right? So if we draw a quick little diagram here, my plane has a northwest heading. So northwest, make sure I know my directions here. So this is going to be northwest, which means that we have an angle measure here of 135 degrees. So we have 450 times cosine of 135 degrees times the unit vector I plus sine of 135 degrees j. And so let's work this out. So since we're in quadrant 2, the cosine here is going to be negative square root of 2 over 2, and the sine is going to be positive square root of 2 over 2. So when I work this out, we have negative reduce 225 times the square root of 2 I plus 225 times the square root of 2 j. And so that's how we can write the plane vector, or the plane velocity as a vector. Now, something we have to keep in mind here is the difference between velocity and speed. So speed is, I would say, is exactly what you think. Speed is how fast you're going. In this case, 450 miles per hour. But speed is actually a component of velocity. Velocity is your speed plus the direction you're going in, because velocity is a vector. So when I put the 450 there, that was the magnitude of the plane. And the direction, so it was the magnitude, it was the speed of the plane, and then of course the direction was 135 degrees. Now the wind is an easterly wind. So that means it's blowing to the right. So I'll use this color. So then we have, so let's see, this is vector P, and this is my wind. All right, so if I were to write my wind vector, it's going to be the speed, the magnitude, which is given to us as 60. And then we have, well, this is cosine of 0 degrees, because we're going straight to the right, plus sine of 0 degrees, j. Now remember that when we were going straight to the right, when we're at 0 degrees, that means that my cosine value is 1, but my sine value is 0. So at the end of this, the way I represent my wind vector is by saying 60I. All right. Now, the next part here is to find the velocity of the plane relative to the ground. And so we're going to do that in terms of the vectors, right? So relative to the ground means that it's not 450 miles per hour in the northwesterly direction, because the wind is affecting that. So for the next part of this question, it's really asking, hey, take these two vectors and add them, and what do we come up with? Well, when I add these, I'm just going to be adding those i's together. And so that gives me negative 165. Nope, I'm about to be careless here. I was about to combine 60 and negative 225, but it's negative 225 times the square root of 2. So those guys aren't like terms, so I'm going to have to do parentheses and say 60 minus 225 square roots of 2, I, and then plus 225 square roots of 2, j. So that's how we would express the velocity, expressing it as a vector. Now this next part here is to find the speed and the direction. So the speed, like the resulting speed of the plane relative to the ground, is going to be this guy right here. So let's find the magnitude of this, which means it's going to be one big square root, and we're going to do 60 minus 225 square roots of 2 squared plus 225 square roots of 2 squared. I'm not going to do this in my head. Otherwise, no. Yeah, I really shouldn't. That's okay. I'm going to go to my handy dandy calculator. Now make sure that you use your calculator correctly, right? Know when you're opening and closing parentheses. So we got 60 minus 225 square roots of 2. Move once to get out of the radical. Close off that set of parentheses, squared. Now we're still inside the big radical. Plus, open parentheses again, 225 square roots of 2. Out of that square root, close parentheses, square that group, and let's see what we come up with. All right, so the speed of the plane was 450 degrees, but with the wind, your speed is no longer 450. Your speed is closer to 410 miles per hour. Also, our heading is not northwest anymore because the wind is definitely blowing us off course. Look at the picture. Northwest would be exactly northwest, right? But we're pushing it over this way. Of course, I think I exaggerated the wind velocity. I could probably cut that back a little bit. So it's more like that, which means my resultant of all of this is going to be something like this, right? When you do that whole tip-to-tail method. Well, let's see what the math tells us. All right, so the tangent of that angle is going to be y over x, or b over a, however you're looking at it. So 225 square roots of 2 over 60 minus 225 square roots of 2. Now, this is not something that we know, so we're going to have to end up doing the inverse tangent, but you've got to be careful about this. Because if I do inverse tangent, and I know that I should end up over here in quadrant 2, inverse tangent doesn't give you answers in quadrant 2. It returns answers in either quadrant 1 or quadrant 4. So we got to keep that in mind. Actually, we also need to change our mode. Let's put this in degree, because that's going to make more sense in terms of bearing. So inverse tangent, 225 square roots of 2 divided by, now since we're dividing by not just a single number, but a couple of different things, use parentheses, 60 minus 225 square roots of 2, whoops. So I'm so used to doing it on older calculators. All right, so this tells me about negative 51 degrees. But again, that's in quadrant 4, right? So how do I fix that? Well, it means that this guy right here is negative 51 degrees. It's like your reference angle, right? Which means the actual one is going to be like this, 51 degrees up from that. So we just do a bit of basic math. we can really just take this guy and add 180 to it, and we get that it's about 129 degrees. So from here to here is 129 degrees. But since we're talking about planes and we're talking about bearing, we want to make sure that we give an angle that makes a little bit more sense. So yes, the theta is 129 degrees. But what we would now say is that the plane is going 410 miles per hour at a bearing of north. So heading north, but going west, right? But not straight west. So what's that number in the middle? And it's going to be the complement here of 51. So it's going to be 39. So north, 39 degrees west. Another way that you can say that, though, is when you do actual bearing, is that we start at north. So you say this is a bearing of, you start here and you go all the way around to this guy. So if you were to wrap around to that, 90, 180, 270, plus 51. So that would be 321 degrees. So when you say a bearing of 321 degrees, what's implied, what's understood is that you're talking about from due north, going in a clockwise fashion. So due north, 321 degrees, so aiming over here, which is still in a northwesterly direction, but not pure northwest, because northwest would have an angle with relative to this horizontal, relative to the east-west line of 45 degrees, not 51. So I hope that makes sense, because you are going at 45 degrees, but the wind is blowing, and it's kind of pushing you to go back a little bit. No, it's over here. Sorry. Backwards and all that stuff. So the wind, you still have the same starting point, but the vectors are going to push you back that way. All right. Hope that made sense to you. If not, let me know. Leave a question, leave a comment, and I'll try to get to you.